4-4, midsegments of triangles. So, on the work together, you're going to need 3 of those triangles cut out. Go ahead and do that first. And then we'll define midsegment as a class. You won't need a book today. We'll actually do that up here. Okay, so now that you have your triangles cut out, this is the work together on page 201. It's kind of a visual of the triangle midsegment theorem that we're going to go through here in a minute. But what I want you to do, each member of your group, you have your triangles. You have 3 of them, so you're working with the person around you. But each of you need to label your vertices A, B, and C on all 3 triangles. That's the first thing, so go for it. Get those labeled. All right, so like I said, I promise I'm not trying to be too fancy, just A, B, C. And now you need to fold angle A onto angle C. So take one of your angles, whichever one you've named A, and fold it over so that this tip, everyone pay attention there, that tip, that vertice touches that vertice. Now you don't have to make a big fold, but it should make a crease, like pinch it right in there where it makes that crease. Okay? So touch angle A to angle C and pinch it where it makes that crease. Everyone with me? Now, if you're looking at these pictures down here, it's going to confuse you. Okay, so everyone like trying to jump ahead and you're kind of looking at pictures, that'll confuse you. Just follow along with me. Okay? So touch here, angle A, touch to angle C, make that crease. Okay, that gives you the midpoint of AC. All right. How many are with me? Okay, you now need to touch angle B to angle C and pinch it and make that crease. Everyone with me? All right, I want you to label where you made this crease from A to C, point L, and where you made this crease from B to C, point N. And then I need you to draw line LN, line segment LN. Actually connect the points. That's going to give you that picture right there. Doesn't have to be exactly, but you should have a line segment LN, and that line segment is called a midsegment. Okay, it's where it connects to midpoints. Okay, now, hey guys, part of our issue will be being able to follow along with directions, okay? So, for those of you that are still with me, how many are still with me right now? Okay, if you're not with me and your neighbor's with me, then maybe follow with your neighbor. You can do it with a different set of triangles here in a minute. Okay? From this point, I want you to fold point C down over this midsegment. So fold your triangle so that it folds on this midsegment. Point C is going to come down and hit somewhere down here. Okay, fold your triangle on LN so that it hits that point. It hits somewhere down there. It's going to give you an envelope looking type thing, kind of like this.
Wait, is point C supposed to like hit directly there, or can I go up?
Should be pretty darn close to there. Uh-oh, that's not a good thing. Yeah. Dude. Just leave it there. That's okay for now. Okay? Do what you can. All right, and then from there, I want you to fold in angle A and angle B. We're going to fold those 2 angles in so that it makes like an envelope. So we fold in angle A to touch where point C is, and fold in angle B to touch where point C is. This is where C hit, right? Okay, So now you have A touching C and you have B touching C. All right? It would be A, B, and C hitting right there. You should have that little rectangle right now. All right, I want to see how many of you could actually follow along. Hold up your rectangles. Hey, well done, man. That's pretty good. Huh? Yep, you take and grab angle A and fold it in to where C is. Help the people around you if they need it.
Wait, is it like this?
Yep. Now here's the deal. You only need one of your triangles to work. So those of you who you're like, man, it messed up. Well, try another triangle. Okay? Let's try it again. Real quick. Work with your partner. You get 1 minute to try it. Then we're going to summarize that theorem. Go ahead and summarize this so you guys can get going on what we're doing today. So Olivia was kind enough to loan me her ABC triangle there. I put the A, B, and C's. And she had it folded down. This was her LN right here. Okay. And we fold it down, we hit, and there, and we know now that this segment, LN, right here, and that, this whole thing makes a rectangle. So what do we know about this segment and this segment? The top and the bottom of a rectangle. They are what? They are parallel. So this thing right here, this mid-segment, everyone stay with me now, this whole point of it, this mid-segment, LN, is parallel to this segment, AB. Those two are parallel. Okay, that's one thing. The other thing is, now when I fold this in, notice this little triangle, everyone see here? This little triangle, LCN. When I fold that down and I hit that, notice right now I have a much longer length on AB than I do for LN up here. Everyone agree? It'd be nice to know how much longer. Well, when I'm able to fold this piece in, you'll notice, what did I do to this side? Just from point C to point B. Yeah, I cut it in half, right? This piece right here, oops, I missed the line. This right here is the same length as that. And notice when I fold this in, what do I do to that side? From A to C. I cut it in half as well. So I want you to talk with your neighbor. How does this length right here relate to this whole length AB? So my new length, when I fold it in, how is that related to that new length? Okay, I heard a few of you kind of whispering it. There's my AB. Well, let's see. I've traced it. I'm using primitive methods here. Okay, I've traced that, and now I folded that in, and I'm just going to mark off this. Maybe that'll help you see it. That's my new length. Can anyone tell me how it's changed? Here's my original AB. After folding, my new AB, so A prime to B prime, goes from here to here. Diamond? Yeah, it's cut in half. He was saying it up here as well. Yeah, it's cut in half. So what a midsegment does, if you take and find a midsegment of a triangle which connects two midpoints, there are two things that are true about a midsegment. A midsegment is parallel to the base of the triangle. It's also, in terms of length, what do we know about the length? Yeah? Yeah, it's half the length of the base of the triangle. So a midsegment of a triangle is parallel to the base, and it's half the length. That's what we know about a midsegment. Okay? So here's your actual theorem. Theorem 4.8 says, if a triangle, or if a segment joins the midpoints of two sides of a triangle, then its segment is parallel to the third and half its length. That's what we just went through there. Okay, that's the mid-segment triangle theorem. We're going to apply that here in a minute on a problem, but right now let's go ahead and get that down there. We're going to do two problems together as a class, and they're right there. So you need to sketch out that picture real quick. Okay? Sketch out that picture. And then I want you to work through this first question. Don't worry about the bottom part right now. Okay? Work through the first question with your groupies there. Okay? Okay, guys, I personally, if I can have your attention back up here, one of the things I see with advanced students, which everyone in this class is advanced, and it's not immune to just advanced students, but this is difficult, and some of you see it. I heard some of you see what you needed to see. I saw some of you not even trying, like some of you just sat there. You didn't even write anything down. You didn't even draw the picture. You're like, okay, well, he'll go through it, so I guess I'll just sit here and twiddle my thumbs until then. Hey, let me give you a hint of reality for some of you that, how many plan on going to college? Okay, your prof doesn't sit up there and do every problem for you. You get to do a few in class, they maybe work through a few things, explain something, and then you get to do a chapter at home or back at your dorm. You better be ready for your test. I mean, it goes much, you're sometimes covering what we cover in a year in a quarter. Okay? So the process means you actually have to put in the effort on the outside. And about a half of you were. Half of you are kind of just sitting there twiddling your thumbs or waiting for me to talk about it. Well, here's your hint. And I'm not going to just feed this to you, but we're kind of wasting our class time. Here's your hint right there. And some of you saw it. Okay? You get another minute to work on it. Hey, I need your attention back up here. Measure of ST and VU if WY is 18. This is 18. Now you'll notice in this whole picture, you've got a quadrilateral. When you start cutting in half, and they tell you that STUV are midpoints, that means this is a midpoint, and this is a midpoint, and a line connecting two midpoints is called it's a mid-segment. So if I want to find ST, how is ST related to WY? WY. Yep. Good. It's parallel, and it's half. So half of 18 is 9. Now, how many got it? Good. How many got it before I gave you the hint? Okay. What's VU? 9. Okay. Now, I want you to draw in XZ. It's labeled, it has a length of 25. And I want you to tell your neighbor what you can find now. And unfortunately, we only get about 2 minutes. Otherwise, you get no time on your assignment today. Hey, here we go. If I draw in this right here, now notice it's not actually in there already. If that has a length of 25, okay, that has a length of 25. What could we find now? Grace?
So now you could continue
All right, good. We connect TU, we connect SV, and they both are 12 and a half. Okay? All right, it's half of 25. Those are the mid-segments of it. Cameron?
Couldn't X be a mid-segment to ST and VU?
Could XZ be a mid-segment to ST and VU? Possibly. We don't know that for sure. Yeah, so there's a possibility it is, but we don't know that. Okay. Any questions? All right. Thank you for participating. One final comment. If I look at this triangle right here, this triangle, let's go with this one, VUZ, the perimeter of that triangle is what in comparison to this big triangle?
Say half.
Everyone agree that's half?
Yeah.
Why is it half? Why is the perimeter of the yellow half of the perimeter of the, is it blue?
Yeah. But UY is half of YW.
Good. These are all midpoints, so all the sides are half the length, right? All right, just so we know. That'll help you with today's.